finding the equation of a sine or cosine function. So now we want to go backward. We've got a graph. We want to write the equation. We've done this before. We just have a few more things to think about now. The first decision is which basic shape should we go with? Well, if you have the choice, go with the easiest thing you can. Go to the y-axis, measure out one full period, and then see which basic shape that is. And this, of course, is the vase, which means regular cosine. Then start listing out your features so that you can figure out A, B, C, and D. The amplitude. Well, let's see. Maybe it would help me to draw in the midline. Looks like the lowest spot is 0 and the highest is 2. The midline would be right here at y equals 1. The amplitude is the distance from the middle to the top, which is clearly a distance of 1. So the amplitude is 1. Well, I'm dealing with regular cosine, so there's no negative. The amplitude is 1, which means the A is going to be 1. How about the period? Well, let's see. Here's one complete period. I need to know what this marking is. It looks like this first tick mark here is pi over 6, which means this would be 2 pi over 6, which reduces to pi over 3. So the period is pi over 3. And then to figure out the B, I can use my little formula, right? B equals 2 pi divided by the period. Dividing by pi over 3 is the same thing as multiplying by 3 over pi, and pi's cancel, and I end up with 6. So my B value is 6. Let's see, then I have the midline. We've already drawn it in. The midline was the equation y equals 1, which means the D is 1. And then what about the phase shift? Well, we decided to start right at the y-axis. That's why we picked regular cosine. There is no phase shift. Regular cosine starts at the high. This graph starts at the high right there. We don't have a phase shift. That means our C value would be 0. I have everything I need to write the equation down. Let's remind ourselves of the general form. So make sure you know this backwards and forwards. All I need to do now is fill in those numbers. The A is 1, which means I don't really even need to write anything there. The B was 6. The C is 0, which means I don't really even have that second parentheses. X minus 0 is just x, so I just have 6x in there. And the D is 1. And we're done. Now, let's say the directions had been a little different. Let's say I was being forced to use the sine function in order to come up with the equation of this graph. In that case, I would have to identify my sine function. In other words, I would look for the simplest hill and valley I could find, the one closest to the y-axis. Most of the information we've written down here would be the same. The amplitude is still 1, the period is still pi over 3, which means the B is 6, the midline is still at y equals 1. All of that stuff is the same. The only thing that would be different now would be the phase shift. Because if I'm going to use regular sine instead of regular cosine, clearly the regular sine function here has been shifted. It's been shifted to the left by this amount. Now, that's half a tick mark. I know what that is because in my scaling here, this would obviously be half of the pi over 6, which is pi over 12. This is just the corresponding spot on the other side, negative pi over 12. So clearly this thing has been shifted pi over 12 to the left. The phase shift is negative pi over 12, which means that's the C, negative pi over 12. I don't have to redo a whole lot to write down my equation. It would simply be y equals sine, and then I'd have the 6. I would have the extra parentheses, and inside it would be x plus pi over 12. Everything else would stay exactly the same. Now, don't miss what we're saying here. This is significant. We're saying that there are really multiple different equations that can be used to describe the exact same graph. Our first one used the regular cosine function. Our second one used the regular sine function by employing a phase shift of pi over 12 to the left. What if I wanted to use the reflected sine function? Could I do that? And the answer is, of course, I would just need to find the simplest reflected sine graph that I could find. So here's a valley followed by a hill. Again, all the information is going to be the same. If I wanted to use reflected sine, the only difference is going to be the phase shift. I can see that this reflected sine has been moved pi over 12 to the right. The phase shift would be positive pi over 12. The c would be positive pi over 12. The a, because it's reflected, would be negative 1. Other than that, everything would be the same. And so my equation here would be very similar. I would have a negative because of the reflection, and then I would have a shift to the right, so I would write x minus pi over 12 instead of plus pi over 12. Here's another equation that describes the same graph. Let's go to the calculator to verify. Okay, so I've gone to the calculator, I've put in the regular cosine equation, then I put in the regular sine equation. I had to be careful with all the parentheses to make sure I entered those in correctly. I did the reflected sine equation just as we did on the paper. What should happen when I hit the graph is that these graphs lie right on top of each other. Let's take a look. So here comes the first one, and then the second one, and then there's that third one. They all make the same picture. Those three equations describe that same graph. Okay, let's try another one. This time, the only thing we're given is the 5 key points. So here they are. We're told that the graph is a sine or cosine graph. We want to find the equation. Well, I would certainly suggest you start by drawing a picture of what's going on here. Let's see, in terms of scale, look at the x coordinates. I see 0, 3, 6, 9, 12. So if I count by threes, I should be pretty safe. The y values, I'm seeing negative 1, negative 3, and negative 5. So those look to be the important ones to mark down. And I'll put dots at those spots. And of course, just doing this is so helpful. I know it's sinusoidal. I can connect it with a nice sine or cosine shape here. Maybe I'll draw on the midline, which is obviously here at negative 3. And I think now we should be able to write an equation for this thing pretty easily. If you have the choice, pick the simplest situation possible. The simplest situation is the one that starts at the y-axis. And that's the way I've drawn it here. And clearly, starting at the y-axis, this is a reflected sine picture. It's the valley and the hill. Okay, amplitude, distance from the midline to the top or the bottom. I guess I could go right here. That's 2 spaces, right, from negative 3 to negative 5. So the amplitude is 2. This is a reflected sine, so that means the a value will be negative 2. The period, let's see, it looks like it goes all the way to 12 before the thing repeats. And then for the b is 2 pi over p, so 2 pi over 12, which would reduce to pi over 6. So my b is pi over 6. How about midline? Well, we drew it in. It's the horizontal line y equals negative 3. So my d is negative 3. And phase shift, at least the way we've done it right now, there is no phase shift. It would just be nothing. C would be 0. Regular sine starts right where we want it to start. Well, that's plenty for me to write down my equation. It's going to be y equals the a, negative 2. We picked sine, reflected sine. The b is pi over 6. I don't have the second parentheses because I didn't need a phase shift, so just x. And then minus 3 for that d value at the end. Here is the equation of the graph that we drew. What if for some reason we wanted to use a cosine? Maybe we didn't even care between regular cosine or reflected cosine. Well, I would just find the easiest one I could. The one that I'm spotting pretty quickly here would be the one that starts here and continues on a little past where I drew it. I guess that would be 15 there if I keep counting by threes. That looks like a pretty simple one to do. That would be reflected cosine. The amplitude is still 2. The a is still negative 2 because it's reflected. Period hasn't changed. Midline hasn't changed. The phase shift, though, if I want to use reflected cosine, this is a reflected cosine that has been shifted 3 to the right. So the c value would be 3. The equation is going to be very, very similar. We said the a stays the same. It's still negative because it's still reflected. Of course, I'd have cosine here instead of sine. And in here, a little bit more complicated, my b is the same. I will have the extra parentheses. with x minus 3 and then the minus 3 at the end from the d value being 3. So here is another version of an equation that would result in that same graph. I'll leave it to you to check this result on the graphing calculator. Thanks for watching.